Okay, we're going to be graphing quadratic functions. So a quadratic function is a function of f of x is equal to ax squared plus bx plus c, so in that form. And remember, if f of x bothers you, think of y, okay? Now, what these things do is, I'm just going to sketch it here, they're going to form a parabola. And so here's my x and y axes, so x axis, y axis, and if I look here, they're going to be the same on both sides of something we call the axis of symmetry. So let's say my axis of symmetry went down through here as, I'll dot this actually, as y, or actually x is equal to -2. So here's x is equal to -2. That's that line there. And this I'm going to say is going to be my axis of symmetry here. So I'm going to draw this, and let's say it goes through there, and then it curves here, and then let's say it goes here. Okay, so a few things we're going to learn here is this is called my axis of symmetry. And, you know, it's the same on both sides of the axis of symmetry. There's going to be either a high point or a low point, which we call either a minimum or a maximum. This is an upward-facing parabola. The shape, again, is called a parabola. This is an upward-facing one, so it's going to have a minimum. We call this point the vertex, and the vertex here is a minimum. Okay? We could have a downward-facing parabola. If we have a downward-facing parabola, we have a -1 coefficient for the a coefficient here. We have a negative, I should say. It doesn't have to be 1, but it's a negative coefficient. Okay, so that's a little background, and that's going to help us graph these. By the way, we have these two things here, which are the x-intercepts. Another name for the x-intercepts are the roots. And the roots are actually solving this equation for 0 is equal to ax squared plus bx plus c. Solving that equation for x gives you the roots or the x-intercepts. So we spend a lot of time working on factoring quadratic equations or quadratic expressions or trinomials. And this is another way to get those roots or to view those roots or those solutions. So here we go. Here's a sample. In this sample, I'm going to have f of x is equal to 4x squared plus 8x plus 3. And first I'm going to find the axes of symmetry. In the axes of symmetry, you can always find by x is equal to the opposite of b over 2a. So, again, this is like the a, the b, and the c. So the opposite of b here is going to be a -8 over 2 times 4, or -8 over 8 is -1. Okay, so that's going to be my axis of symmetry. So what I'm going to do to start graphing this is I'm going to draw my axes here. So this is my vertical axis or my y-axis. And this is my x-axis. So I'm going to go ahead and draw that. And actually, I should have drawn that down a little bit. So actually, I'm going to move this down because I actually know what this one's going to look like, and I need quite a bit of room. So I'm going to move my x-axis down a little bit. And I'm going to go here. And there we go. And so I know, first of all, that my axis of symmetry is -1. So I'm going to go here, and at my -1, I'm going to draw a dashed line. It's a dashed line because the axis of symmetry is not really part of the parabola we're graphing except at the minimum here, the vertex. Okay, so there's my axis of symmetry. Now, once I get the axis of symmetry, I'm going to find I'm going to find the minimum or the maximum here. Again, here it's a minimum. So what I'm going to do, I know that I'm going to say y is equal to 4x squared plus 8x plus 3. So that's the function we have. But here I'm going to find actually what y is. So I'm going to say y, and we know the minimum is going to be on this axis of symmetry. So I'm going to set x to the value on the axis of symmetry there. So I'm going to say 4 times negative 1 squared plus 8 times negative 1 plus 3. And I'm going to get y is equal to 4 plus a negative 8 plus 3. And so 4 plus 3 is 7 plus a negative 8 is a negative 1, which just happens to be same as the x value, but that's okay here. So our point here where the minimum is going to be is the point with xy coordinates negative 1, negative 1. So it's going to be right here. Now, the rest of this, I'm going to start using a table to get other values. So I'm going to list here as x, and then I'm going to go 4x squared plus 8x plus 3, which is going to give me y, and then that should do it. I'm going to try, first of all, 0. So 4 times 0 squared plus 8 times 0 plus 3 is simply going to give me 3. Let's try, so let's do this one. Here is 0, 3. And then on the opposite side, the same distance, on the opposite side of the axis of symmetry is going to be another point, so I can put that right there. So I get 2 points for 1, basically. Now I'm going to try 1. I go 4 times 1 squared plus 8 times 1 plus 3. I'm going to get 4 plus 8 plus 3, which is 15. So this is going to be a really skinny one. So I go 1, 15. This is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's going to be my other point. My other 2 over on the axis of symmetry in the other direction is going to be up here. And now I'm going to put in a smooth curve through all of this. So I'm going to go here. I'm going to go down all the way, try to make as smooth as curve as possible. Then at that minimum, and then back up to this point. Go a little past, put arrows on both ends, and there I graphed it. Now, other thing I'm going to show you is, let's look at what these mean again, these roots. Because remember I said those are the solution to this equation. So there's that equation. Now, I can solve that equation by factoring that. And if you play around with that a little bit using our factoring techniques, it factors to 2x plus 1, 2x plus 3. I know I can find the value of x on both of these if I set these each to 0 and then solve, and I subtract 1, I get 2x is equal to negative 1, divide by 2, divide by 2, I get x is equal to negative 1/2. If I go here, if 2x plus 3 is equal to 0, And I'll move up here. I'm sorry, I lost you a little bit there, but you can see where I've caught up. And subtract 3 from both sides. I get 2x is equal to negative 3 divided by 2. I get x is equal to negative 3 halves. Well, if you look here, this is where x is equal to negative 1 half. It's the x-intercept, or the root. And then the other x-intercept, or the root, is over here, and that indeed looks like it is negative 3 halves, or negative 1.5. Now, one other thing that we're going to talk about, because your book talks about it a little bit, is the domain. Remember, the domain are the x values. The domain here can be any value of x, so we're going to say x is a set of all numbers such that x is equal to all real numbers. But y is more limited because we know that y has to be greater than negative 1 here, because there's no values of y down here. They're all up this way. So the range, or the set of y values, is equal to the set of all numbers y such that y is greater than or equal to negative 1. So that's a little bit about how to graph quadratic functions. Hopefully that will be helpful.